Welcome to LFI Educates. Today we are going to start this chapter 3, motion in a straight line. Here the moment I say motion in a straight line, it comes from classical mechanics. Or we call it as Newtonian mechanics. Mechanics is a branch of science that deals with the study of motion of objects. It deals with the bodies in motion or the objects in motion. This branch of mechanics or this branch of physics, we call it as classical mechanics or Newtonian mechanics. Mechanics is broadly classified into two parts, that is your classical mechanics and the other one that you study as quantum mechanics in higher classes. This classical mechanics is further classified into three parts, that is your statics, or simply we say static. Then the second part is your kinematic or kinematics, and the third part is your dynamics. These are the three parts of classical mechanics. In static, the body is at rest, it is not in motion. The body will be at rest, or the object at rest. This branch of mechanics we call it as statics. And then when you say kinematics and dynamics, in both the cases the objects will be in motion. So kinematics is that branch of physics that deals, or the branch of mechanics that deals with the objects in motion. And dynamics, when we say, then also the objects are in motion. But here the difference is that in this case we are not interested because of what the object is moving. Whereas when we say dynamics, then because of what the objects are in motion, that there we will have to focus. And we all know that force is the agent. From here force will come. By applying force only we can make the objects to move. That part will study in dynamics. These two are time dependent. They depend on time. Whereas the static, when a body is at rest, then it does not depend upon time. The branch of mechanics we call it as statics. In statics, the major thing what you learn is a body at rest. Body is said to be at rest if it does not change its position with respect to its surroundings. Then if a body, suppose this duster, if I keep it here, it is at rest because it does not change its position with respect to the surroundings. Surroundings are the board, this marker, with respect to this marker, with respect to my body, the object is not moving. So that we can say that the body is at rest, or the object is at rest. But when we come to kinematics, the one what you are going to study now, this is from kinematics, this motion in a straight line. In this case, the body will be in motion. We'll define it. We can define like this: motion. A body or an object is said to be in motion changes its position with respect to its surroundings, then we'll say that the body is in motion. Suppose this duster now is moving. This body is moving. We say that the body is in motion with respect to its surrounding, the board, the marker, my body, respect to all these objects, it is moving. So we can define like this: it is said to be in motion if it changes its position with respect to its surroundings. Now, this term plays a very important role here. Without the help of the surroundings, we cannot define rest and motion. If you simply say a body is at rest, if it does not change its position, then the sentence is incomplete, because rest and motion, they are not absolute terms. If they are absolute terms, then I would have stopped here. Even the second definition also I would have stopped here. They are called relative terms because they need something here, its surroundings. With respect to the surroundings only, we can define them individually, rest and motion. That's why rest and motion are called relative terms. They are called relative terms. They require surroundings, then only we can define them. Now, no object in this universe is absolutely at rest or absolutely in motion. With respect to some object, the body may be in motion. With respect to some object, the body may be at rest. Let us see such examples. Like suppose I am standing still here. With respect to you, with respect to the board, I am at rest. But we know that our earth is revolving around the sun. So along with the earth, I am also moving. With respect to the sun, I am in motion. So one object may be at rest with respect to some object, but with some object it may be in motion. Just you can take some examples, like suppose you are inside a bus, you are sitting inside a bus. With respect to your neighbors, those who are sitting nearby you, you are at rest. But with respect to the road or electric pole outside the road or nearby houses, you are not at rest. With respect to the electric pole, the nearby houses and the road, you are in motion. You are moving. The whole bus is taking your body also along with it. So you are in motion. So there is no such absolute rest and absolute motion. They are just relative terms, we say. Now, in regard to this, kinematics we will be studying in this chapter, whereas dynamics it will start from chapter number 4. Now let us see the different types of motion. Motion, the types of motion is categorized like this based on the path they travel, based on their path. The first one is called rectilinear motion. If the motion of the body is in a straight path, then that motion can be considered as rectilinear motion. Suppose an athlete is running 100-meter dash. That is an example of your rectilinear motion. Or a boy sliding down an inclined plane. Even though it is oblique, it is in a straight path. So that also can be taken as motion in a straight line, that is rectilinear motion. The second one, your circulatory motion or circular motion. If a body goes round a circular path, an athlete running a 400-meter race, one round completing, or 800-meter, 2 times completing around the circular path, or Earth going around the Sun in a circular path, that also we can consider it as a circulatory motion, or we call it as circular motion. And the third one is your oscillatory motion. In oscillatory motion, the body will pass back and forth. Suppose this is a rigid support, this is a string, and pendulum bob is hanging here, a solid mass, heavy object is hanging. If you pull the bob a little bit and then release it, after pulling here, if you release it, then it will start to oscillate, we say. Why do we say that it oscillates? Because it goes and comes back to the same path. This is the mean position. It crosses the mean position, again it goes to the other end at A. This point is supposed to be B. So it keeps on moving like this. To and fro motion. To and fro motion. If there is to and fro motion of an object, or you can take an example of a swing. When you are swinging to and fro about the mean position, that is also an example of oscillatory motion. Sometimes this oscillatory motion we call it as vibratory motion also. Vibratory or vibrations also we say, because if there is vibration, then what will happen is the number of oscillation will become very fast. If the number of oscillation becomes very fast, then that motion we call it as vibratory motion. These are the 3 types of motion based on their path. Now let us see on the basis of number of coordinates required to define them. Types of motion based on the number of coordinates. Number of coordinates required. If you take in terms of coordinates, then 3 types, 2 types are very familiar. A number line, you know, all of you. The first one, suppose this is the origin 0, 1, 2, 3, 4. It may be in kilometer, it may be in centimeter, or it may be in meter, let us say meter. This side, you know, it is -1, -2, -3 and so on. Then you are also familiar with this x-axis and y-axis, because you have been drawing graph in smaller classes or smaller grades. To locate a point, suppose P, you require a plane. To locate the point P, x value you need to know. Suppose it is 1, 2, then you write here 2. Then y-axis, suppose it is at 3. 1, 2, this is 3, then you write here 3. So in a plane, if you do, then it is called a 2-dimensional. In a number line, we call it as, you talk about or we discuss about an object flying in space, suppose an aeroplane in the sky or a bird flying in the sky. Then we require 3 coordinates. This is called 3-dimensional. These are x-axis, I am drawing on the positive side, y-axis and z-axis pointing towards you. But I cannot draw a line like this, so I have to draw and show you like this. But you have to know that it is this way. So in this case, this is your xy plane. Here there are 3 planes like this. xy, this is z-axis. xy plane, this is yz plane. And then another plane, that is xz plane. So 3 planes will come. So in this case, if an object is in space, suppose a bird is here. Here is the bird. Then it does not come in xy plane, it does not come in xz plane, it does not come in yz plane. It will be here. It is in space, 3 dimension. Then you will have to see at what distance the object is from x-axis, at what distance the object is from y-axis, at what distance the object is from z-axis. Then in that case we require this 3 dimension. But here drawing time will appear like as if it is in xy plane, but it is neither in xy plane nor in xz plane. It is nor in yz plane also. It is in space here. So this position to describe, you will have required 3 coordinates: x value, y value and z value. So in this case, we will call it as three-dimensional motion. So number of coordinates required. Suppose a boy is walking on a road, then with one dimension you can define it or you can express it. Or if you take a stone and if you throw up, then we are interested in how high the stone will go up, and we are interested in what will be the horizontal range or horizontal distance that it will go and fall. So in that case, we require only two dimension. This is the horizontal direction to give you, y-axis will give you the vertical direction. In that case, the motion of an object will take it as two-dimensional. That we will learn in chapter 5, that is motion in a plane. But whereas this one, we study a little bit lately, little bit only maybe studying in class 11. But in this case, the example already I said, a bird flying in the sky, or because the bird may go up also, may come down, it can go horizontal distance also, it will travel like this. At the same time, if a bird wishes to fly this way also, it can go, that way also it can come, any direction it can fly. So in that case, we require this three-dimensional motion. We are interested in which side the bird is going to fly. We never know. Left, right, forward, backward, up, down, any direction he may go or he may fly. So in that case, we require this three coordinate system, x, y and z, and we call it as three-dimensional motion. So I'll write down here, based on the number of coordinates required. Number 1, that is one-dimensional motion. Then you can see the diagram. This is in number line. You can see. Yeah, you can take this one as x-axis. You can take it as y-axis also. When this is only one dimensional, we can take it as x also, y also. We can imagine as z-axis also. Doesn't matter, but it will be a single line. Then in case of two-dimensional motion, you can see here I gave you the example of an object being thrown high up, then does not have its own energy to travel left, right, this way, that way. It cannot go. It can only travel higher up, and it can only travel horizontally. The distance you can find. Then in that case, we use this two-dimensional motion. And the third one, that is your three-dimensional motion. In three dimension, an object in space, when you study, that time will require this three-dimensional motion. So these are the 6 different types of motion that you can describe. Now let us learn one term called point object. In physics, you come across this point object. Point object is that object whose size is very, very small as compared to the distance it travels. If the distance traveled is very far, suppose from here to Delhi, from Dimapur to Delhi, and then you are going to travel by a train. So the train can be considered as a point object. We know that train is not that very short, but the distance it's going to travel is very, very far, more than 1000 kilometers. So compared to the size of the train, the distance is more. That's why the train can be considered as a point object. Our art, as you all know, that is not a small size. It is very big, we know. But art can also be considered as a point object compared to the distance it travels around the sun. Its orbit around the sun is very large. So art also can be considered as a point object. So you can define it very easily. What is a point object? Then you will say that an object can be considered as a point object if the distance traveled by the object is very large as compared to its size. Then that object can be called as a point object. The next thing that you'll have to know is about scalar and vector quantities. Scalar quantities are those quantities which has only magnitude. Magnitude means its value. It does not have any direction. Those type of physical quantities, and what is a physical quantity we have discussed in the earlier videos, that any measurable quantity we call it as physical quantity. Here physical quantities are of two types, scalar and vector. When you say about scalar quantity, it has its magnitude, like say time. Time, it is a scalar, 2 hours, 3 hours, or 4 minutes, or 2 seconds. So it does not show any direction. So time can be considered, it is unidirectional. One side, time never waits for anybody. We say time and tide waits for none. The same thing here. Backside cannot go, it goes only front, in one direction only, unidirectional. So time comes under the scalar quantity. Like length, mass, these are examples of scalar quantities. Suppose 2 kg, you never say minus 2 kg, minus 8 kg, like that we never say. We always represent in terms of positive value. So these quantities we call it as scalar quantity, or 2 gram or 2 milligram. So these are examples of scalar quantity. It does not show any direction. It has its value. These values are called the magnitude. Its values are called the magnitude. These are all its magnitude. These are magnitudes of mass. These are magnitudes of time. So scalar quantity does not show any direction. Vector quantities. These vector quantities shows both magnitude as well as it has a direction. Which side it is moving. Suppose say in a number line, this is the origin 1, 2, 3. These are in suppose say meters, and this side is -1, -2, -3. We know, particularly when we discuss about motion in a straight line, then we'll take either x-axis or y-axis. One axis only we can take. So if we are moving towards the right, displacement is this side positive, this side it is negative. So we can get both positive value as well as negative value. So when I write displacement, suppose 1 meter, then you will understand that, oh, I have moved this side, right side. If I write -1 meter, then you will understand that, oh, I have been displaced on the other side. So like that, it will have both positive as well as negative value. That will show you the direction, magnitude, the value itself, and the direction. The sign will show you. Here if I write positive displacement, this is negative displacement, that will give you the direction as well. Like that, velocity, you have a vector quantity, it shows both magnitude and direction. Then you have acceleration, you have force, many other physical quantities you come to know later, that it has both magnitude as well as a direction, and those quantities we call them as vector quantities. The next thing that you have to know is about position, path length, path length is also known as distance, and displacement. The location of the point or the location of the object initially, at an initial stage, we call it as position. The object started at 8 a.m. from O. So where is the position of the object and where it is located? At 8 a.m. it is located at 0 here. So this is the position of the object. After 2 hours, suppose the body has traveled this way and reached here at B at 10 am. Suppose it has reached here at point B. So where is the position of the object? Then we will say where it is placed at point B. That gives us the position of the object. Now when you talk about path length, or we call it as distance or path length, the exact path traveled by the body, that we call it as the path length. The exact path, or the actual path traveled by the body is called path length, or in other words we call it as distance. Now in this case, suppose the body moved from A to B. So the path length is, supposing this is in kilometers, say the values here 1, 2, 3, 4, then we will say that it is 3 kilometers. The actual path traveled by the body is called the path length, or we call it as a distance. Suppose the body did not stop there and then it came back here at 2, at point C, say. Then what will be the path length? Here 3 kilometers and here 1 kilometer. Altogether how much? The total path, we'll have to measure it, the actual path. So from A to B it is 3 kilometers, from B to C it is 1 kilometer. So it's 3 plus 1 will give us a 4 kilometer. That will be your distance or actual path length. And the next thing you have to know is about its SI unit. Is meter. In unit and measurement we have come across the SI unit is meter, and its dimensional formula will be mass, not there, or better not to write, as I said earlier, m power 0, no need to write, only length 1 will write down, does not have time, it does not have mass. So it will be L within the square bracket. They will give you the dimensional formula. Now let us say about displacement. Displacement, the change in position of an object in a specified direction is known as displacement. So it is a change in position. In physics you very frequently come across this word change in. It may be change in position, it may be change in velocity, it may be change in acceleration. This word change in indicates what is change in. Let us see first of all. Change in is final minus initial. That we call it as change in. In physics, when you say change in position, if we are discussing motion in a straight line in x-axis alone, then xf minus xi, f indicates final, I indicates initial, final position minus initial position, that will give us the change in position. If you are talking about change in velocity, then it will be velocity, final velocity minus initial velocity. If it is change in acceleration, it will be final acceleration minus initial acceleration. So these are all change in, but we are talking now, right now we are talking about change in position. Change in position, when we say, then the final position minus the initial position. Displacement mathematically we can write like this. Final position minus initial position, that will give us displacement. Final position if you write xf, initial position if I write xi, then this difference will give us the displacement. Now let us see this number line again. Displacement can be positive displacement if final position is bigger than initial position, will get positive displacement. Suppose say 5 km minus initial position is 2 km. 5 minus 2 will give you 3. So that will be your positive displacement. Let us see here with diagram. This is the origin. 1 km, 2 km, 3 km, 4 km, 5 km. Suppose you know that the body was placed here initially at 2 km. From here, this is the position of the body. Body has moved up to 5 km at point B. Then initially it was at A, finally it is at B. So if xf is bigger, then here it will be 5 km minus 2 km. Then you will get positive displacement. It will be plus 3 km. We are talking in terms of kilometer. The unit will be kilometer. So it will give us positive displacement. Displacement can be 0. It can be even 0 and it can be even negative also. Let us see first negative displacement. If xf is less, final position is less than initial position, then it will give us a negative displacement. Suppose the body moved from A to B. After that, it has come from B back to C, suppose here, C. It has come from B to C. Then in that case what happens? Your final position becomes 1. The final position becomes 1 and initial position is still 2. You started from A, went to B and then came back to C. So in that case, final position is 1 and initial position is 2. Final position is 1 and initial position is 2. So it will give us minus 1 km. So like that you can get negative displacement. Negative displacement when you get is from the point where you start, if you go forward, after that if you cross that position and come back, then you get negative displacement. Displacement will be on the other side. And lastly, zero displacement. If xf and xi, initial position and final position will become both equal, then you will get a zero displacement. Suppose the body started from A, went up to B and then came back to A again. This time it has come back to A again at the same position. The initial also, final also, the value is 2 km. So 2 minus 2 will give you 0 km. So these are the three types of displacement will come across: positive displacement, negative displacement and zero displacement. Now let us do one small numerical, then it will become more clear about your distance and displacement. Now let us solve this question. It will become clear about distance and displacement. But before starting this numerical, displacement is a vector quantity, as I already said to you, and its unit is also same as that of distance, that is meter, and its dimensional formula is also same with that of distance. It is length, meter, only length you have plus 1 dimensional formula for displacement. Now do this question. A boy starts moving from minus 20 meter. This is the position of the boy initially. This is the initial position. Towards positive x-axis. This side is your positive x-axis as shown in the figure. He turns at time instant t2. That means he reaches at plus 40 here. And then at time instant t2, he turns and starts moving towards negative x-axis this side. At t3. At t3 he reached. He reached at minus 50. I have repeated here. He reached. One time only you will take it. He reached at minus 50 meter. Here, minus 50 meter. Find the distance and displacement. You have to find both the distance and displacement for the time interval t1 to t2. First, we'll do this one from t1 to t2. So, solution if you do for the first one, for the time instant t1 to t2. Distance and displacement to find out for time interval t1 and t2. To find out the distance is a scalar quantity as we know. We'll measure the distance like this from 20. Here is the starting position. This side is 10 meter. 10 meter, 20 meter, here negative, nothing will come, plus distance is the actual path traveled by the body, so it is 20 meter, plus from 0 to 10, 20, 30, 40, this side you have 40 meter, so altogether you will get 60 meter, this will give you distance. And when we say displacement, you have your final position minus initial position as a formula. Final position you will see plus 40. This is plus 40 minus initial position is minus 20. So xi is minus 20. So it will give you 40 minus into minus is plus 20. Both are in meters. All are in meters. So it will give you 60 meter. So it shows direction. 60 meter means which side the body got displaced, that means towards the positive x-axis. So plus it came up towards positive x-axis. Like that for the second case from t1 to t3. Let us see here. For time interval t1, for the second case, t1 and or t1 to t3. Let us see the distance first. From t1 to t3 means from t1 he traveled up to t2, then he came back to t3. So t1 to t2 you already know the distance is 20 plus this is 40. 20 plus 40 plus 20 plus 40 plus from 40 again you can count 10, 20, 30, 40, 50, 60, 70, 80, 90. So it will come out as 150 meter. This is the total distance, the actual path traveled by the body. From here you count again, he has to come back up to here. So the whole path length you have to take it to find out the distance. But when you say displacement, then you are not interested in the path length. We are interested in the positions. Final position minus initial position will give you the displacement. Final position is minus 50 and initial position is minus 20. So it will come minus 50, minus into minus is plus 20. It will give us minus 30 meter. That is towards negative x-axis. Negative x-axis. So So like this we can find out the distance and displacement. You can see very clearly here was the body and it got displaced this much only, 20. From 20 to start this is 0, 10, 20, 30. As it is towards negative side, the body got displaced by minus 30 meter. With this, we'll come to the end of this video. We'll continue with next video. We'll learn some more new things. Thank you and have a nice day.